Students, in this video, I am going to go through some exercises with you guys on testing whether or not two functions are indeed inverses of one another. So, having gone through the last video on a lesson on doing just that, the theory was if you take two functions that you understand to be inverses of one another and perform this operation, the composition of those two functions together, what you will get is the identity. And it doesn't matter whether you take the inverse and you put it into the original, or you take the original and put it inside of the inverse. Both of them should come out with the value of x. If this is the case, then the two functions are indeed inverses. So let's take a look, okay? I have no idea which one's the inverse of who, okay? So it doesn't matter which one I do, okay? So g of f of x, let's say, okay? Let's see. So 4/5 times x, right? But instead of writing x, I'm going to write in f of x, which is negative x minus 2. And you can sort of see already this is not going to come out to equaling x. This is going to be negative 4/5 x minus 8/5. So this is not. So g and f are not inverses. All right, let's take a look at the next one. Very similar idea, okay? So this one is a little more obvious. So let's do it in reverse. Let's do f of g. So f is 5x, right? But instead of writing x, I'm going to write 1/5 x. And from that, I can see that, yes, it does equal x. So this is yes, they are inverses. Let's take a look at the next one. This is a cube root function. All right, things are getting a little more intense. Okay, so let's take, what I'm going to do, okay, is I am going to take g of f, and it really doesn't matter which one, which order I do it in, okay? So what I will get then is cube root of x, but instead of writing x, I'm going to write in f, right? So it's negative 2 minus cube root of 4x all over 2 plus 2 and then minus 1. So in order for me to go through simplifying this, remember, this all has to reduce down to x. It doesn't have to, right? We're testing to see whether it actually does or not. So in order for me to continue with this, okay, I'm going to create a common denominator. You can already sort of tell that this is not going to work, because what should happen is the cube root should cancel, and here clearly we see that they are not going to, but this 2 here will become a 4, right? So it's plus 4 over 2 minus 1, and this will become cube root of negative 2 minus cube root of 4x plus 4 all over 2 minus 1. So we can see clearly this is not going anywhere. We get 2 minus cube root of 4x all over 2 minus 1. So this is not, f and g are not. Okay? And moving on. Okay, so here we have, again, very similar. I am going to do f of g. Of x. And it really doesn't matter which one we do. We could do it in either order, right? F of G or G of F. What did I do in the last one? Yeah, I did G of F. So here, again, I take F, which is open parentheses x plus 2, right? So instead of writing x plus 2, instead of writing x, I want to put in cube root of x plus 3 minus 2. That's x, right? I'm replacing x with g. And then plus 2 cubed minus 3. The positive and negative 2 goes to 0. I'm left with cube root of x plus 3 cubed minus 3. Well, what's the cube of cube root? That's just x plus 3. And then don't forget the minus 3. The positive and negative 3 cancels. I'm left with just x. So yes, F is an inverse of G. All right, moving on. And again, no particular order. Let's do G of F. So this is negative 2 over x minus 2, right? But instead of writing x, I'm going to write in F, which is 2 over x minus 1 minus 1. This whole thing minus 2, and then plus 2. It's like, whoa, what are you talking about? So again, this, what I'm putting in parentheses there, that was x originally, right? But I'm replacing, wherever I see x, I'm replacing it with f. All right, so I get this like complicated looking fraction thing, and don't be afraid of this. This negative, I can move that anywhere I'd like. Okay, I'm going to place that up top so I don't have to worry about it. The denominator here, okay, I am going to open the parentheses and combine like terms. I get 2 over x minus 1 minus 3 and plus 2. I am going to continue simplifying the denominator until I get a simplified common denominator, and this whole entire big fraction turns into just a single fraction. So I get negative 2 over x minus 1 minus 3 times x minus 1 over x minus 1 plus 2. This will equal negative 2 minus 3 times x minus 1 all over x minus 1 plus 2. We're almost there. So I'm going to continue simplifying. I get negative 2. The denominator, the numerator of the denominator becomes 2 minus 3x plus 3 all over x minus 1. When you guys are doing this, make sure that you draw this fraction bar large enough to distinguish between what's actually the numerator and what's actually a denominator. I've seen a lot of students in the past where they draw a fraction bar not long enough, and then they sometimes get confused as to, well, which one is the real numerator and which one's the real denominator. Anyway, so this becomes negative 2 all over 5 minus 2x all over x minus 1. Remember, calm and methodical, okay? So now I'm dividing fractions. So this is negative 2 divided by the denominator, right? But it's really the same thing as multiplying by the reciprocal of the denominator, so it's x minus 1 over 5 minus 2x. Whenever you're dividing fractions, okay, you're multiplying by the reciprocal. And we're almost there. This is negative 2x plus 2 over 5 minus 2x plus 2. And create common denominator again. I get negative 2x plus 2 over 5 minus 2x plus 2 times 5 minus 2x over 5 minus 2x. So this becomes negative 2x plus 2 over 5 minus 2x plus 10 minus 4x over 5 minus 2x. And this can all be reduced to, when I combine like terms, the negative 2x and negative 4x makes negative 6x. The 10 and 2 makes 8. All over 5 minus 2x. So clearly this does not equal x, right? So because of this, we can conclude that f and g are not inverses. Because if they were inverses, this would all equal to x as a result, and it doesn't. All right, let's take a look at the last one. Okay, so what we want to do, again, h of f of x, and really it doesn't matter, how we enter it. So this is negative 2 over x minus 1. So it's 2 over negative x plus 2 plus 1 minus 1 plus 2. This thing right here, remember, this is f, and that was originally x inside of h. So I'm replacing x with f, and that's how I end up with this. One more time, I am going to clear the denominator. I get negative 2, or not clear the denominator, but simplify it. I see that the positive and negative 1, they cancel. I get 2 over negative x plus 2. I am going to clean up the fraction by dividing the denominator, and that is the same thing as multiplying by the reciprocal. So it's negative 2 times negative x plus 2 over 2 plus 2. The negative 2 and positive 2, they cancel. I'm left with negative x plus 2 plus 2. This becomes x minus 2 plus 2, or this just becomes x. So you can see the difference between this example and the last problem that we did, that if they were inverses, you can start to see things canceling out and reducing really dramatically, really quickly. So that's another hint, okay, at whether or not the two functions are indeed compositions of one another. So f and h are inverses.